Okay, welcome to the next problem. So for the second problem of axial deformation, we have here in an aluminum bar rigidly attached so that we have to prevent lateral buckling. So therefore, this bar is not subject to a buckling or bending effect. Okay, so as we notice here, we have 6,000 leftwards force and another leftwards of 5,000. So all in all, we have there as 11,000 going to the left to be resisted by 7,000 and 4,000 going to the right. So in short, this bar is not subjected to any movement or any acceleration because it satisfies the axiom of mechanics in terms of equilibrium. So the cross-sectional area is given 0.5 inches squared, and then the axial loads, the dimensions, and the modulus of elasticity. So this is 10 times 10 raised to 6 pounds per square inch. So we are going to compute the total elongation or the total change in the length of the bar. So again, we're gonna use here the principle of the axial deformation. So we have delta is equal to PL over AE. So since we have here three segments of 3 feet, 5 feet, and 4 feet, so let us apply our technique in method of sections. So in method of sections, we usually cut the member. See, I'll just use this figure. So we usually cut the member. See, the section method is a method wherein we cut the member and we just consider the left or right portion. Okay, so that is to recall that one. So in this first segment, of course, it is very convenient to use the leftmost portion because it has a lesser details on the left. Okay, so that is for the segment 5 feet, we can cut this and consider the left or right portion. So in this case, I'll just use the left portion. Okay. And then for the last segment, you can cut this one, and of course, obviously, life would be easier for us if we're going to consider the right portion because it has a lesser details on the right portion. So this section shall be labeled accordingly. See, we have here a section AE, section BB, and a section CC. So first, let us draw the section simultaneously at AE. What will be the figure? So if this is the first segment that is cut at this section, and then we are going to consider the left portion, the first present here is 6,000 pounds, and obviously 6,000 pounds is an arrow moving away from the member. So basically what we do is to assume a direction here, right? And it is obvious to assume that this is towards right because it is just resisting the force of 6,000 away from the member. So if this arrowhead is away from the member, the resisting force should also be away from the member. So by summation forces X is equal to 0 to satisfy equilibrium, we just have here PA is equal to 6,000. So if we have an arrowhead that is away from the joint, that is considered as tension. We have to indicate that because if we have tension, we have a stretching, and if we have a stretching, we have an additional load. That is why we have to indicate that this is tension and this is a positive length. Okay, so next, considering the section BB at section BB, okay, first we have to draw BB. It covers two segments here but cut into the middle. Of course, all the forces on the left portion will be considered now. First we have here the 6,000 and rightwards 7,000. Okay, so what we do next is to assume a direction for the internal force. So it is important to note here that between 6,000 and 7,000, this is oppositely directed. If we are going to subtract that one, it will be having a 1,000 force, prevailing force towards right, isn't it? So it is towards right. So if we do not know that one, of course we can always assume a direction for that, but obviously it is much better, or it is much rational to assume that this is going to the left portion. Okay, so doing that, we just have to write this one, summation forces along X is equal to 0. So doing that, we have negative 6,000 plus 7,000. So this is PB, right? Minus PB is equal to 0. So solving for PB, obviously this is equal to 1,000. Now the arrowhead of the PB here, basically we have a positive result positive result just simply means that we have a correct assumption on that. So correct assumption of having a arrowhead towards the joint. So the meaning of that one, if the arrowhead is towards the joint, that is in compression. So when we compress the body, it is shortening the length. So we're going to indicate that by a negative sign. Okay. So again, let me have here a scenario of section BB, the same section. Say we have here 6,000 and this is 7,000. What if we have assumed that this arrow or the resisting force is towards the right, say this PB? So there will be no problem, just apply the same principles of summation forces X is equal to 0. Just the same, this is negative 6,000 because it is towards the left portion. Just the same, this is 7,000. But this one becomes now plus PB is equal to 0. So PB will yield at same answer, but we have negative 1,000. So what is the meaning of negative? It is assumed incorrectly, so we need to correct that one. Now correcting that one, we'll just have to reverse the assumption we had, because in our equation it was incorrectly assumed. So there is no problem with that. Just remember that if we have a negative sign, we have just assumed a wrong direction and we have to correct that. And correcting that, just the same, we yield an arrowhead that is towards the body. So therefore, just the same, PB is equal to positive 1,000, but this should be in compression. And again, compression is denoted by negative sign. So that's the procedure. Okay, so may we now proceed to the section CC. So at section CC, obviously this is the scenario. This is cut at the left portion. We have here 4,000 away from the joint. So it is easy to see that the resisting force is away from the member also, that is equivalent to 4,000 there. Thereby PC here is equal to 4,000. This is in tension and it is a positive length. So perhaps we can erase this portion. Finally, delta total is equal to delta 1 plus delta 2 plus delta 3. So we have here PL over AE of 1 plus PL over AE of 2. Sorry. So we are in ABC. A, B, C, A, B, and PL over AE of C. So PA is equivalent to 6,000. The length is what? We have here PSI and inches. So therefore, the feet unit here should be converted into inches. So investigating the unit, in 1 foot, there are 12 inches. So if we have 3 feet here, so feet, it will be multiplied, it should be multiplied by 12. So the conversion factor of 12, and then we divide, or perhaps we can merge all of the denominator by the single AE. Okay, so next we have here minus. Why minus? Because we have minus or compression for PB. 1000 times the length is 5 times conversion factor of 12. Okay, is it for the meantime. And then finally for PC, plus PC is tension, that is why that is positive, times the length is 4, the conversion factor is 12, and then the merging denominator is AE all over the area. So what's the area? 0.5 inches squared times 10 times 10 raised to 6 psi. Okay, so computing now the total deformation, we have 6,000 3 times 12 minus times 5 times 12 4,000 times 4 times 12 divided by 0.5 divided by 10 divided by 1 million. We have 0.0696 inches. Okay, so this is the answer for this problem. Okay, thank you, and get ready for the next video on problem number 3.